Hello and welcome back to the Cracking Thing YouTube channel. Today we're solving Leetcode 1493, longest subarray of ones after deleting one element. Given a binary array nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only ones in the resulting array, and return 0 if there's no such subarray. Let's look at a very basic example here. So we're given this array 1101. Obviously, we have to delete one element from it, and logically, we're going to get rid of the 0, which leaves us with this array, 1111, and obviously there's 3 ones in there, so the length here is going to be 3, or it's also the length of the subarray. So that is, our solution. So let's look at a more complex example, where in this one we have multiple zeros, so we basically have to choose which subarray we want to get rid of. So potentially, if we get rid of this 0 here, we could have this subarray. And what's the longest consecutive ones? Well, it's 3 here, right? So that's one potential solution, is 3. What if instead we chose to get rid of this 0 here, which means that we'd have the subarray until the end. So if we got rid of this 0, then we have 1, 2, 3, 4, 5. So that's another potential solution. So we can have basically either 3 or 5. Obviously the one with 5 is going to be better. Or we could potentially get rid of this 0, which would mean that we have the subarray, let's see, well we have a 3 here, but we can't count it because there's a 0. So we can count this block, which would just be 3 and 3. Unfortunately, we can't combine those two. So the best solution we can actually get is this 5. So looking at this problem, it's pretty easy to figure out how you need to do it if you're just doing it kind of on a piece of paper, but doing it in code is a little bit more complex, but still not that bad. And the approach that we're going to use here is actually a sliding window. And what we want to do is basically we just want to keep track of basically how big our window is. So we're going to keep track of kind of our left pointer, so where our sliding window is, right pointer where our sliding window ends, and then how many zeros we've seen in our sliding window. If the number of zeros that we've seen ever exceeds 1, then we know that we need to start reducing our sliding window by moving the left towards the right pointer, such that we can start removing those zeros, because remember, we're only allowed to delete one element. So as soon as our kind of our sliding window contains more than 1 0, then what we need to do is just get rid of it. And at each iteration of our sliding window, we can basically take the maximum of whatever the result that we've computed so far versus the width of our window. So right minus left, and at the end we'll just be left with whatever our solution is in whatever variable we store our results in. So that's the general approach. We're just going to go from left to right. We're going to maintain a sliding window left and right. We're going to keep track of the zeros we've seen. If we've ever seen more than 1 0 in our current window, then we're going to start moving the left pointer up. And really, that's all we need to do. So let's now go to the code editor, type this up. It's really about only 10 lines of code, so I'll see you there. Okay, so we are in the code editor. Let's now type this up. We're going to need a few variables here to basically go through our solution. So we need to basically keep track of the number of zeros we've seen and also what our best solution is so far. So let's define those variables. So we'll have zeros, and this is going to equal to result, and at the beginning it's just 0. Now we need to keep track of the start of our sliding window. So let's set that equal to 0 as well. And what we're going to do is we're going to iterate over our kind of given nums here from right to left and keep track of kind of the sliding window. So we're going to say for and num in enumerate nums. What we're going to do is now we need to check whether or not our current number is a 0. So we're going to say zeros plus equals. So we're going to add 1 to our zeros if the current number is a 0, otherwise we don't add anything. So we're going to say 1 if num equals 0, else 0, right? So basically if the current number is 0, add 1 to zeros, otherwise don't add anything to it. Now what we need to do is, now that we've added a 0, we actually need to double check whether or not we have more than 1 0. If we have more than 1 0, then we're not allowed to take this 0, and we need to actually reduce the size of our sliding window by moving start up. So what we're going to do now is we're going to say while zeros is actually greater than 1, we're going to say 0. So we need to start moving elements from our start position. So we're going to say we're going to subtract from zeros the current number if it's a 0, right? If we've seen a 0, then we can remove it from our position. So we're going to subtract 1 if nums of the start position of our window equals to 0. Otherwise, we don't subtract anything, right? We only subtract when we see a 0. We don't subtract when we see a 1. Now we need to move the start of our window up 1, and we're going to continue this process until zeros is either basically equal to 1 or less than 1 for our current window. But most likely it's going to stop when it equals to 1. Okay, now what we need to do is basically just take the maximum of whatever the result we've seen so far and the difference between the end of our window and the start of our window, and this will be our new best result. So either it's going to be the previous result or whatever the size of our current window is. And we're going to do this basically for all the indexes and nums in nums, and at the end all we simply need to do is return our result and we're good to go. So let's just run this, make sure we didn't make any mistakes, submit it, and we can see that it is accepted. Perfect. Last thing we need to do is just touch on the time and space complexity. Obviously for the time, all we're doing is iterating through numbers from left to right. We're just doing some simple checks. We're not performing any sort of computation that isn't big O of 1. So our time complexity here is simply just going to be big O of n. For the space complexity, as you can see, we don't define any extra variables other than these kind of pointer variables, which are holding just integers. So because of that, our space complexity is just big O of 1. So relatively straightforward problem, nice simple sliding window. Great for learning this type of pattern. And yeah, that's how you solve this problem. Hopefully you enjoyed the video. If you did, like and comment and subscribe. Really helps me grow the channel. Otherwise, thanks so much for watching, and I'll see you in the next one. Bye.